Okay, here's an example problem from another physics book. It says a box, mass 0.5 kilograms, traveling at 5 meters per second across a smooth horizontal floor, slows to 3 meters per second over a distance of 30 meters. Determine the magnitude of the frictional force acting on the box and the coefficient of kinetic friction between the box and the surface. The best thing to do here is step 1, always draw your diagram. So we have all our variables. We have our 5 kilogram box. The 5 meters per second represents the V initial. The 3 meters per second represents the final. And the displacement, which is not 3 meters, it's 30. Which is 30 meters. Now we want to find the magnitude of the frictional force. So we start by drawing all the forces acting on the box. So we have a force of gravity pushing down. And the force of gravity is always mass times gravity, which we actually know. We know the mass is 0.5 kilograms and the gravity is 9.81. So this is equal to 0.5. Then we have our normal force pushing up, which we don't really know. And then since it's moving in this direction, because that's what this arrow means, we're going to make sure that there's a frictional force going to the left. So because the box isn't moving up or down or accelerating, we know that the net force in the y, which equals mass times acceleration in the y, that's going to equal 0 because the box isn't moving up and it's not moving down. So that means the normal force minus the force of gravity is going to equal 0. So that means they have to be able to cancel each other out. So we know that the normal force minus because it's pointing down, that's going to have to equal 0. So that means the normal force has to equal 4.905 newtons. For the net force in the x direction, that's going to be mass times acceleration in the x, which is not going to be 0 because it's going from 5 to 3, so that means it's decelerating. So what we first have to do is use that information to find our a. Since we know the v initial, the final, and the x, we can use the equation vx squared equals vi squared plus 2ax. So we get 3 squared equals 5 squared plus 2a times 30. So we get 9. Negative 16 equals 68. We divide by negative 16 by 60. We get negative 0.27 meters per second squared is the acceleration of the box. So we use that acceleration here. So that means the net force in the x is the mass times this acceleration. And we use the mass of the box as our m. We get this is going to equal 0.5 kilograms times 0.27, negative 27, which is going to equal negative 0.133 newtons. And the net force in the x direction is just all the forces in the x direction, and all the forces in the x direction. Well, since there's only one force, it's just going to be the force of friction. So this is going to equal the force of friction. So this is going to equal the force of friction. And it makes sense that our force of friction is negative because it's pointing towards the left. So that's R, the magnitude of our frictional force. So this is part A. It's right there. And for part B, they want us to find the coefficient force. So we know that the formula for the force of friction is equal to the coefficient of friction times the normal force. Now we know the force of friction is negative 0.133 newtons. We don't know the coefficient of friction. That's what we're trying to find out. And we know the normal force, which we calculated before, is 4.905 newtons. So that means if we divide 4.905 newtons, we get the coefficient of friction to equal 0.027. Notice that I took away the negative because the coefficient of friction is like an absolute value. It's unitless. So that's your final two answers.